Mass spectrometer is an analytical tool used for measuring the mass-to-charge ratio of one or more molecules present in sample. This measurement can also be used to calculate the exact molecular weight of a sample component as well. Typically, mass spectrometer can be used to identify unknown compounds via molecular weight determination, to quantify known compounds to determine structure and chemical properties of molecules. How does mass spectrometer perform such a feat? Every mass spectrometer consists of at least these three components: 1. Ionization source, 2. Mass analyzer, 3. Ion detection system. Number 1. Ionization source. Molecules are converted to gas phase ions so that they can be moved about and manipulated by internal electric and magnetic field. In our laboratory, we use technical called nano-electrospray ionization, which is somewhat similar to how cars are industrial painted. This method allows for creating positively or negatively charged ion, depending on experimental requirements. Ion electrospray ionization and direct couple of the outlet of the small-scale chromatography column directed to light of mass spectrometer. Number 2. Mass analyzer. Once ionized, the ion are shortened to separate according to mass-to-charge ratios. There are a number of mass analyzers currently available, each of which has trade-offs relating to speed of operation, resolution of separation, and other operational requirements. The specific type in use at the board institution are discussed in the next section. The mass analyzer often works in conjunct with the ion detection system. Number 3. Ion detection system. The separated ions are then measured and sent a data system where a mass-to-charge ratio are stored together along with their relative abundance. A mass spectrum is simply the m/z ratio of the ion present in the sample plotted against their intensities. Each peak in a mass spectrum shows a component of unique m/z in the sample, and weights of the peak connote the relative abundance of the various components in the sample. How mass spectrometer work, and what are the different parts of spectrometer? So, spectrometer is not available here, so I want you to show this video from Dr. Posprenda in his YouTube channel. Watch this.
Hello friends, today I am going to explain about instrumentation and the working of mass spectrometer through animated video. Now coming to the different parts of mass spectrometer. So first one is slit A, second one is slit B, third one is slit C, fourth one is slit D, fifth one is slit E, sixth one is detector, seventh one is amplifier, eighth one is recorder. Now coming to the various chambers present in mass spectrometer. So first chamber is sample vaporization chamber. It is present between slit A and slit B. Second chamber is ionization chamber. It is present between slit B and slit C. Third chamber is ion acceleration chamber. It is present between slit C and slit D. Fourth one is mass analyzer. It is present between slit D and slit E. Now coming to the first chamber. So here sample will be inserted, and in second chamber, that is sample ionization chamber. In this chamber, electron gun will be present in the form of tungsten filament. In this chamber, electron collector will also be present, which will collect the electrons. Now coming to the third chamber, it contains various electrodes. First electrode is supplied with positive potential. Second electrode is supplied with negative potential. Third electrode is supplied with more negative potential, and so on. So it will accelerate the ions. Now coming to the fourth one, that is mass analyzer. So in the mass analyzer, magnets will be present and they will form magnetic field, and due to that magnetic field, deflection of the ions takes place. So this is all about instrumentation of mass spectrometer. Now coming to the working of mass spectrometer. So first sample will be inserted through slit A into the sample vaporization chamber, and here if sample is present in solid or in liquid form, then it will convert in the form of vapor due to heating, and the heating is given by heating coils. Now this vaporized sample will go further through slit B and it will enter into the ionization chamber. Now electron gun will produce the beam of electron and that will strike the molecule, and due to this electron beam, molecule will lose one electron and ultimately it will convert into the form of positive ion, and this positive ion is known as radical cation or molecular ion. Here energy produced by electron beam will be approximate 70 electron volt, and ionization potential for the molecule will be approximate 10 electron volt. So due to high energy, M plus ion will convert in the form of fragment ion also, that will be M1 plus or M2 plus, etc. Now these positively charged ions will go towards the slit C, and their positively charged electrode potential will be there, and due to this positively charged electrode potential, these positive ions will be repelled in the right side, because in the right side negative potential will be there, and ultimately they will get some velocity, and with that velocity they will enter into the mass analyzer through slit B. And the low molecular weight compounds will be deflected high, so path length will be higher, so ultimately large molecular ions will reach to the detector first, then a smaller molecule will reach to the detector, and ultimately at the last smallest molecule will reach to the detector. Now these molecules will be detected by the detector, and here photomultiplier tube is used as a detector, and ultimately this signal will be transferred towards the amplifier. Amplifier will amplify these signals, and finally it will be recorded in the recorder, and we will get the mass spectrum. So this is the complete explanation about mass spectrometer and its working. For more details you can watch my video lecture on instrumentation of mass spectrometer. Link is given in the description. Thank you.
And that's all about mass spectrometer. Thank you for watching. Bye bye.